Hi parents and families, this is Crystal Strader, Curriculum Facilitator of Middle School Math with Gaston County Schools. For this month's Parent Academy video, we're going to talk with you about strategies for dividing fractions. Before we begin, let's take a look back at a division of fractions problem and think back to when we were in school. How did you learn to divide fractions? I'd be willing to bet many of you are thinking keep, change, flip right now. The problem with tricks like this is that the math is not visible from the trick. What are we keeping? What are we changing? What are we flipping? Why does this work? And when we start to combine that with other tricks like keep, change, change, which is not the same as keep, change, flip, and is used for something other than dividing fractions, things can get really jumbled in students' heads to the point where they don't understand the math at all. So in this video, we'll talk real quickly about those pitfalls of using tricks in mathematics. And to understand that, we're going to look at how students' understanding of division of fractions progresses from grades 3 through 8. As we do that, we'll look at a variety of visual and algebraic methods for dividing fractions and talk about how those methods connect and move student learning forward. And then I promise we'll get to why does keep, change, flip work and where's the math behind that. So let's start in third grade. In third grade, we start working with dividing whole numbers. There's two fractions. When people see the problem 6 divided by 3, most people think of it one of two ways. So the first one is the partition method, which is where we take the 6 holes or 6 whole cookies, and we're going to fair share them between 3 bags. So we're going to divide those into 3 bags, and so each bag would get 2 cookies. Then the measurement or repeated subtraction method would involve if we took those 6 cookies and we wanted to put 3 cookies in each bag, then we would fill 2 bags with that. Regardless, we get 6 divided by 3 is 2. Then in 5th grade, students start to look with division of fractions. They specifically work with what we call a unit fraction, which is where the numerator is 1. So let's look at, notice that these problems are reverse of each other or opposites of each other. So let's see what that happens or what happens with that. So in the first situation, I've got 1/3 of a pizza left, and I'm going to divide that amongst my 6 friends. I don't think they're going to like me very much. So here I've taken the 1/3 of the pizza that's left, and I've divided it into 6 pieces. So really everybody's going to get 1/6 of 1/3 of the pizza. But we have to remember that the pizza is the unit here. That's the whole. So what they're really getting is 1/18 of the whole pizza, which is a very tiny slice. So I've decided I'm going to be a little bit nicer to them. So if we look at the opposite, if I take 6 whole pizzas and I divide them into serving sizes of 1/3 of the pizza, here you can see I've divided each pizza into thirds. And so I could serve 18 friends with that. That definitely gives me more friends. Now, it is important that we notice that these are opposites of one another. That is significant, and we'll talk about that a little bit later. But those visual models really help us to understand and visualize what's happening when we divide by those fractions. So as we move into 6th grade, we start dividing fractions by other fractions. So here let's look at a recipe calls for 2/3 a cup of sugar for 1 batch of cookies. And we have 6.5 cups of sugar. So we want to know how much we can make. Now for students that are now just learning or need that visual for dividing fractions, this is a great virtual resource. Most people don't have the little manipulatives that we have in schools for dividing fractions. So this is a great option. So here what we'll do is, or what we can see is that I have the 6, so 1, 2, 3, 4, 5, 6.5 batches of cookies, or cups of sugar, and then we have 2/3 a cup is going to be for 1 batch. Now the first thing I'm going to do is what I really want to see is how many of these 2/3 fit in this visual model, but I noticed that I'm going to have some extras left over here, so that's going to be kind of weird. So what I'm going to do is I'm going to divide each of my halves into thirds, and forgive me if my lines are not perfect. I'm doing this with a mouse. I don't have a touch screen at the moment. So if I divide them into thirds, what I've really created is each of these sections is a 6. So 1, 2, 3, 4, 5, 6. Okay. So now I notice that 2/3 is really equal to 4 of these smaller sections. So what I'm going to do is I'm going to keep moving this, adding this in, making copies of this to see how many of these little 2/3 pieces I can fit into my 6½ cups. So what you can see here is I was able to make 9 full batches, and then down here we have this random half. Well, we noticed that to make a full batch, we needed 4 of those smaller pieces. Well, we have 1, 2, 3 of the 4 smaller pieces that we need to make a whole batch. So what we learned from this is that 6½ divided by 2/3 is 9 3/4. Now, it's important to remember that that is 9 3/4 batches. The question here is asking how many cookies we could make, which we could multiply by 12 and figure that out. But this is what's important, that we could see that we have 9 3/4 there. Now, in 6th grade, we start to envision that, okay, well, if I had anything more than 6½ cups of sugar in this problem, to sit there and draw that out would be a tedious task. It would take me a long time. So we start to summarize our learning to see what's going on here. So let's first think about what we did. So when we looked at this, the first thing I did was I recognized that 6½, so we started with 6½ divided by 2/3. I recognized, oh, well, there's really 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, well, 2, 4, 6, 8, 10, 12, 13. There's 13 halves. So just realizing that as an improper fraction is important. Then what I did is I divided each of those halves into thirds. And what I realized that I did was I actually, making sure I did this right, is I divided each whole cup into 6. So what I have, if I count each of those smaller sections, if I keep going all the way, so 37, 38, 39, is what I really did was I made this 39/6. And then we understood that a batch, 2/3, was really 4 of those 6 pieces. So what we did here is we found a common denominator of 6. And by doing that, we realized that, okay, well, we can just take 39 and divide it by 4. And 39 divided by 4, because we're much easier thinking about 3rd grade, would be 9 3/4 batches. So we would get the same thing. So if we convert to a common denominator of 6, then we can divide just the numerators. So then we get to 7th grade. And 7th grade is where that standard algorithm of keep, change, flip really starts to come into play, but we need to understand why it works. So let's come over here to a different model. So in this visual, we have the exact same 6½ cups of sugar, and think about the math that we did the first time. If we divided each of these, we split them into thirds. So I'm going to split these into thirds. Okay, and so we realized by doing that, and I have to think down here, that's going to be a little bit different. So what that did, by dividing it, or by splitting into thirds, I really went from having 6½ pieces to, if I count these, I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. So the top part is going to be 18. And then down here, so this 1/2 piece is a full third and then a half. So 18 plus another 1½. So we have 19.5 pieces. So back to the problem, what we did was 6½, and we multiplied that. We created 3 times as many pieces, which was 19½ pieces. Then if we come back to our model, we decided that our batch was 2/3. So then we started dividing by 2. So let's come in here and I'll highlight them. So a batch is going to be 2/3. So we've got 1, 2, 3. That's a terrible color to use. Let's try something else. Let's try this. So 1, 2, 3, 4, 5, 6. And remember, we started to have the randoms over here. 7, 8, 9. And then we had the 3/4 of a piece left. We have to kind of envision what's happening here. So the next thing we did, if we come over to this, so we had 19.5, then we divided this by 2, and we got 9 3/4. Well, let's think about what happened here in this math. So the first thing we did is we multiplied by 3, and then we divided by 2. So it's like we did the opposite here. So that is why keep the first fraction, so 6 1/2, change to multiplication. So we changed to multiplication, and so we multiplied by 3 and then divided by 2. So that is why keep, change, flip works and gives us 9 3/4. So then by the time we get to 8th grade, students are expected to use the keep, change, flip, or what we call the standard algorithm. What we officially call this in math is to multiply by the reciprocal. So what this means is to take 6 1/2 and divide it by 2/3. I'm going to multiply by the reciprocal of 2/3 is 3/2. This is what we should say. Instead of remembering keep, change, flip, we want to say multiply by the reciprocal. In 8th grade and on up, as we're solving equations, students are expected to use that algorithm, which was way faster, multiplying by the reciprocal, to solve problems instead of drawing out those visuals. So here, in the last step of this equation, I know I need to divide both sides by 7, 6. So divide by 7, 6. So what I'm really looking at is 3 divided by 7, 6. So I know that I can solve that by multiplying by the reciprocal. So what I'm really going to do is take 3. I'm going to multiply by the reciprocal of 7, 6 is 6 7ths. Now remember, any whole number is just a fraction with a denominator of 1. So we have 3 times 6, which is 18. And then 7 times 1 is 7. So 18 7ths. Well, if we're thinking about that, 7 goes into 18 2 times with 4 7ths left over. So we would say that x is 2 4 7ths. And that's much more efficient. But what we understand here is the math behind it, as opposed to keep, change, flip, where we don't understand what's happening. So I hope you found this helpful. And thank you for watching. We'll see you next month.